Now we move to another important topic, and it is the concept of field of view. Now this concept of field of view is very important in optics. Now let's understand what is this field of view. I told you in the beginning, and that is the fundamental point of optics, that whether it is object or image, to be seen by human eye, the rays on eye lens should be in diverging fashion. Now when we say field of view of image or object, we mean the region from where we can see object or image. That is simply referred as field of view of object or image. Now to put it more precisely, we can say the region where diverging rays from object or image are present, that will be the field of view of object or image, as the case may be. Now let's understand the few points which we have to keep it in mind. The very first point, that to find out the field of view of image, we have to consider limiting or the extreme reflected or refracted rays, because we know that image is formed after reflection or refraction. So I repeat it, to find the field of view of image, we have to consider extreme reflected or refracted rays. And the second point, to find the field of view of object, we have to consider extreme incident rays. Now we know that incident rays decide object. So to locate the field of view of object, we have to consider extreme incident rays. Now let's understand these 2 points using ray diagram. Now we have taken a mirror as an optical system, and an object is in front of mirror. Now to find its field of view of object, so we consider extreme incident rays. Now the field of view of object is marked on the diagram. Now to find the field of view of image, we have to consider corresponding reflected rays, that is corresponding to extreme incident rays, we have to consider extreme reflected rays. Now the diagram is very clearly showing the extreme reflected rays. Now these extreme reflected rays decide the location of or the region from where we can see image, which is referred as field of view of image. Similarly, we can take up one example where our optical system is lens. So here we show properly the extreme incident rays, which decides the field of view of object, and finally refracted rays, which are forming a real image. Now again we have to remember that field of view of image or object is a region where diverging rays are present, because for image or object to be seen, our eyes must receive these rays in diverging fashion. So field of view of image is marked as a shaded region, and we can see this image anywhere from the field of view. Third point that we have to understand very clearly, that as far as virtual object is concerned, now human eyes cannot see virtual object, because in case of virtual object, incident rays will be converging on the eye lens. Now image will not be found on the retina. So we can say virtual object has no field of view. Now to understand this concept in more detail, let's consider few numerical problems based on it. Now this problem, which appeared in IIT JEE 2003, it appeared in screening, and this is a problem based on the concept of field of view. Problem says we have a point object, and it is a light source S, and it is placed at a distance L in front of a mirror in the center of mirror of width D. Now a man walks in front of mirror along a line which is parallel to the mirror at a distance 2L. Now we have to work out the distance over which man will see the image of source while walking on this path. So let's analyze it. and let's do the relevant calculations. Now first thing, this problem is based on the concept of field of view. Now the man will see the image of source in mirror so long as he is in the field of view of image. Now to find the field of view of image, we have to consider extreme reflected rays. Let's construct the ray diagram and let's consider extreme reflected rays which are corresponding to the extreme incident rays. Now using the property of plane mirror, we take two incident rays which are hitting the two edges of plane mirror and the corresponding reflected rays, and these reflected rays intersect the line along which man is walking at point P and Q. So when man is above Q, he will see the image, and when he is above P, he will be out of field of view. That means we have to calculate PQ. This is our required distance over which man will see the image of source in the mirror. Now going by property of similar triangles and considering similar triangle, that is MMI and PQI, we get D, that is small d over L, is equal to PQ over 3L, and that gives me the value of PQ as 3D. So our answer required will be 3D. Now one thing we have to remember, that source is placed in front of mirror and it is placed in the center, and the width of mirror is D and source is placed symmetrically. So the image will be formed at the same distance behind. So our final answer will be 3D. Now we move to another problem which is based on this concept of field of view. Here we have an insect walking along x-axis and it is moving with a speed of 1 meter per second, and we have a plane mirror of length √2 meter and it is placed along the line y is equal to -x. We have to calculate the time for which this insect will see its image. Again it is a similar problem but asked in a slightly different fashion. Now the insect will see its image so long as he is in its field of view. Now the line y is equal to -x, definitely it makes an angle of 45 degree with negative x-axis. The length of mirror is given to be √2 meter. Now from the end A of mirror we draw perpendicular which is cutting x-axis at point C. It is very clear if we just do the analysis, so long as insect is beyond C, the rays from the bodies of insect will hit the edge of mirror A and will form image, and if we consider other extreme reflected ray, it will go along negative y-axis. Definitely our insect is out of field of view. So we identify point B as the point when insect will start seeing its image. The moment insect is beyond B, definitely it will be in its field of view and insect will see its image up to origin. So we have to calculate BO, and from simple trigonometry the value of BO is 1 meter, and we have to calculate time taken by insect